The illusion of time. Imagine for a moment time stands still. The ticking of the clock is nothing more than a distant echo. The hands are frozen in place, unmoving. The sunset lingers at the horizon, trapped in a never-ending pause, where the day and night refuse to meet. The world, seemingly alive and in motion, is suddenly caught in a perfect, suspended moment. No forward movement, no past, no future. Just an endless now. What if this frozen moment is closer to the truth than the rushing current of time we feel every day? What if the very concept of time, the thing that governs our lives, our actions, our understanding of the universe, is an illusion? What if time, as we know it, doesn't actually exist at all? These are not just idle philosophical musings. They are questions that scientists, physicists, and philosophers have grappled with for centuries. Time, the ticking clock that orders our days, the thing we measure in hours, minutes, and seconds, is something so fundamental to our understanding of reality, yet it remains one of the greatest mysteries of the universe. And what if this mystery is more profound than we ever realized? What if everything we've come to accept as time is not a fundamental aspect of the universe, but a construct, a mental framework that arises from our limited perspective of a far more complex reality? This is the central theme of our journey, the exploration of time as an illusion. Time is often treated as a constant, a river flowing from past to future. It seems so obvious, so undeniable. We feel it every moment the passage of time. Our lives unfold in its current. We grow older. We experience the rush of moments passing us by. Every event, every experience seems to happen in the ever-forward movement of time. Yet the more we look at time, the more we realize that something doesn't quite add up. Time might not be the immutable force we've always thought it was. Let's start by considering something simple, something we all feel: the flow of time. The idea that time is constantly moving forward past to present to future seems like the bedrock of our experience. But what if this progression is nothing more than an illusion created by our minds? What if time's steady march forward doesn't reflect any deeper truth about the universe, but is simply a quirk of consciousness? To understand this, we need to think about how time feels. Our experience of time seems to be linear, doesn't it? We wake up, move through the day, and rest again. Every moment seems to lead into the next. We measure it, we mark its passage. But even in our subjective experience, time doesn't always feel the same. Sometimes it stretches, like when we're waiting for something we dread or anticipating something we desire. At other times, it races past us, like when we're immersed in a conversation or lost in the thrill of an adventure. We experience time in a highly subjective manner, shaped by emotions, perceptions, and consciousness, but science tells us something different. Physics, particularly Einstein's theory of relativity, shows us that time is not the constant, unchanging force it seems. Time does not flow at a uniform rate. It can stretch, slow down, and even bend. According to relativity, time behaves differently depending on the observer's motion and position. A clock moving at high speed will tick slower than a clock at rest. Time bends around massive objects like stars and black holes, creating curves in space-time. Time, as a simple, linear flow, falls apart when we examine it on a universal scale. Let's pause here for a moment. What does this mean for us? How can time be so flexible, so malleable, when we experience it as a constant, implacable force? We've all heard about time dilation, the phenomenon in which time slows down for objects moving at very high speeds. Astronauts aboard a spaceship traveling near the speed of light would experience time much more slowly than people on Earth. If they spent a year in space, they might return to find that decades had passed on Earth. It sounds like science fiction, but this isn't just theoretical. It has been observed, tested, and proven through experiments with atomic clocks. Time, it turns out, is not universal. It bends, warps, and behaves in ways that defy our everyday experience. But time's fluidity doesn't end with relativity. On the smallest scales, quantum mechanics presents an even deeper challenge to our understanding of time. At the quantum level, particles behave in ways that seem to violate the very idea of a consistent flowing timeline. Quantum entanglement, for instance, shows us that two particles can be linked, with the state of one instantaneously affecting the state of the other, even if they are separated by vast distances. This defies our classical understanding of time and space. If information can travel instantaneously, it seems to suggest that time doesn't always work in a linear fashion across the universe. This brings us to a crucial question. Is time itself a mental construct? Could it be that what we experience as the passage of time is actually a product of our consciousness, an illusion designed by our minds to make sense of the world around us? What if, at a fundamental level, time doesn't exist at all? Perhaps what we call time is merely the result of how our brains interpret the flow of events, not a true feature of the universe. This idea might seem absurd at first, but philosophers have suggested this for centuries. Take Immanuel Kant, for example, who argued that time and space are not external realities, but ways that we structure our experience. According to Kant, we cannot experience the world outside of our own perception. The very way we perceive reality is filtered through the mental constructs of time and space. This suggests that time is not something out there, but something we impose on the world in order to make sense of it. And then there's the idea that time might not even exist in the way we think it does. Could it be that time is a loop, a repeating cycle, an illusion that arises from our finite perception of an infinite reality? The universe may not be marching in a linear direction, but may exist in an eternal now, a timeless, interconnected moment where past, present, and future are one. In this view, time is not a river flowing from one moment to the next, but an ocean where all moments coexist simultaneously, perceived only as distinct by the limits of our consciousness. As we dig deeper into the illusion of time, we are left with more questions than answers. If time is an illusion, what does that mean for our experience of reality? What does it mean for our understanding of existence, of the universe, and of consciousness itself? Time, it seems, is not the simple, unchanging force we thought it was. It is a complex, mysterious phenomenon that, like so many other aspects of reality, is far more fluid, subjective, and tied to consciousness than we could have imagined. This documentary will take you on a journey through time, not as a linear progression, but as a living, breathing concept that defies our expectations. From the quantum realm to the cosmic scale, we will explore how time bends, warps, and might even vanish entirely. And along the way, we will ask the most fundamental question of all: what if time is not real at all? The tension between our subjective experience and the findings of modern science will guide us, and as we continue our journey, we will dive deeper into the nature of time itself, confronting the illusion we live by and uncovering the possibility that what we know as time might not exist in the way we've always believed. The linear flow of time. How we experience time. Imagine waking up in the morning. The sun rises, the clock ticks away, and without even thinking about it, your mind places events in neat, ordered boxes: past, present, future. You sip your coffee, remember what you did yesterday, and begin planning for tomorrow. Every action you take, every thought you think, is a product of this constant, relentless flow of time. It feels inevitable, unchanging, like the very rhythm of existence itself. But what if time, this ever-flowing river that guides our lives, is nothing more than an illusion a trick of the mind? Why, if science suggests time might not behave the way we think, do we experience it as so tangible, so undeniably real? The linear flow of time, the progression from past to present to future, forms the foundation of our experience? Our lives are shaped by time's passage. We measure it, structure our days around it, and weave it into the very fabric of our existence. And yet there is something deeply perplexing about our perception of time. It is as though we live within its flow, carried along by its current, yet unable to see it from the outside, from any perspective other than one bound by its ticking rhythm. From the moment we are born, we are taught to understand the world through the lens of time. As children, we learn to count the days, mark the hours, and understand the shifting of seasons. Time becomes our framework, our primary organizing principle. But time is not just a way to measure the world, it shapes our experience of the world. Psychologists have studied how we experience time, and they have found that our perception of time is remarkably subjective. A minute can feel like an eternity, or it can slip by in the blink of an eye, depending on what we're doing, how we feel, and even how old we are. The time paradox is something we all experience. Time seems to speed up as we age, with the days passing faster and faster, leaving us wondering how it all slipped away. For example, think of a child eagerly awaiting their birthday. Time seems to drag on forever. A week feels like a year, but as an adult, time rushes past. What was once an agonizing wait for a single day becomes a blur of years, months, and minutes that pass unnoticed. Psychologist John S. Dunn described this as the time compression phenomenon. The older we get, the less we notice the passage of time. This subjectivity of time is one of the most compelling aspects of our experience. Time doesn't feel the same when we are relaxed as it does when we are anxious. It doesn't flow the same way when we are immersed in a task we love, as opposed to when we are waiting for something to happen. When we are engrossed in a conversation, the minutes slip away unnoticed. When we are bored, each second stretches into infinity. But while time feels real to us, it is not so simple in the world of science. The laws of physics, particularly in the realm of quantum mechanics, tell us that time is not as straightforward as we experience it. In the quantum world, time does not behave in the same linear, predictable way that we see in our everyday lives. In the microscopic world of subatomic particles, time seems to lose its directionality. Quantum particles exist in a state of superposition, meaning they can exist in multiple states at once until they are observed. This state of possibility exists outside the typical flow of time. When you measure the position of a particle, the wave of possibilities collapses and the particle assumes a definite state, but the order in which that happens seems to blur. Time, in this sense, is not fixed. It is malleable, uncertain, shaped by observation. This brings us to the philosophical puzzle. If time is nonlinear in the realm of quantum mechanics, why do we experience it as flowing from past to present to future? The arrow of time, as it's called, appears to be a fundamental feature of human experience. We remember what happened in the past, live in the present, and anticipate the future. Yet, at the quantum level, this linear progression appears to break down. We are left with a mystery. How can our subjective experience of time be so linear when at its core, time might not behave this way at all? Philosophers have grappled with this paradox for centuries. One prominent theory is eternalism, which posits that all points in time, past, present, and future, exist simultaneously, and the flow of time is merely an illusion. According to this view, time is like a block. All moments exist equally, but we only experience them one after the other because of the limitations of our perception. This idea directly challenges our intuitive experience of time as a progression. In eternalism, the past is just as real as the present, and the future is already laid out. Time's flow is not real, it is an illusion produced by our consciousness. Then, there's presentism, which argues that only the present exists and the past and future are mere concepts. In this view, time flows in a linear direction, and our experience of it is aligned with its true nature. But even presentism has its limits, especially when we consider quantum mechanics. How does presentism fit with the uncertainty of the quantum world, where particles exist in superpositions of states untethered to any one moment in time until measured? The idea of a single, fixed present seems to unravel at the quantum level. Both of these theories, eternalism and presentism, struggle to reconcile the experience of time with the strange behavior of particles in quantum systems. But regardless of the theoretical framework we use, the experience of time as linear remains deeply embedded in our perception. We cannot shake the feeling that time moves in one direction forward, away from the past and into the future. This tension between the subjective experience of time and its scientific implications creates an ongoing mystery. So, why does time feel so real to us, even when science suggests it may not be? Why do we intuitively experience time as moving forward when, at its deepest level, time behaves in ways that defy our expectations? The answer may lie in consciousness itself. Our perception of time is not just a passive experience. Time feels real because we are experiencing it through a conscious filter, a lens shaped by our thoughts, our feelings, and our sensory experiences. Our minds are wired to interpret the world through a narrative structure: past, present, future. And this narrative structure is something we project onto the world. This mental framework helps us navigate life and gives meaning to the passage of events. Yet as we begin to understand that time might not be what we think it is, we are forced to confront the possibility that the way we experience the world is fundamentally shaped by our consciousness. What we perceive as a smooth, uninterrupted flow of time might be a mental construct shaped by our awareness that we project onto the external world. The more we explore the science of time, the more we realize that our subjective experience, our sense of the passage of time, is not an objective reality. It is a mental model, an illusion that helps us make sense of the universe. And while this perception of time may be real to us, it may not be real in the way we've always assumed. As we continue this exploration, we will dive deeper into the scientific concepts that challenge our perception of time, seeking to understand why time feels so tangible to us, even as it bends, stretches, and shifts in ways we cannot fully comprehend. And as we do, we will ask ourselves, if time is not what we think it is, what does that say about our place in the universe and how we understand the flow of existence itself? Einstein's relativity. The fluidity of time. We live our lives as though time is a constant. Every morning we wake up to the ticking of a clock, the rhythm of the seconds passing as we move through our daily routines. The past is behind us, the future ahead, and the present is the narrow slice where we exist. It all seems so fixed, so predictable, like the ticking hands of a watch that never stop, always counting down, never straying from their rhythm. But what if time, this constant flow we take for granted, is nothing more than an illusion? What if time isn't as fixed as we think? What if, in reality, time is more like a river that can bend, stretch, and change course depending on where you are, how fast you're moving, and what kind of forces are at play? Enter Albert Einstein. A century ago, his groundbreaking theory of relativity upended our entire understanding of the universe. Time, Einstein showed, is not absolute. It is fluid, shaped by velocity, gravity, and the very fabric of space-time itself. And once we understand this, the world as we know it begins to bend and twist in ways that defy our every instinct. One of the most mind-bending aspects of Einstein's theory is the concept of time dilation. Time, Einstein proposed, does not flow at the same rate for everyone. Time slows down for objects moving at high speeds, and it slows down even further the closer you get to a massive object like a planet or a star. This is time dilation, the phenomenon where the faster you move, the slower time passes relative to someone who is stationary. It sounds strange, almost like science fiction, but it has been proven again and again in laboratory settings. To grasp the impact of time dilation, imagine you are traveling on a spaceship, racing away from Earth at nearly the speed of light. While you're aboard the spaceship, everything feels normal to you. You wake up, eat your breakfast, and watch the stars outside your window just as you would on any normal day. But here's the twist. From the perspective of someone on Earth, you are moving at an incredible velocity. As you travel faster, time begins to slow down for you. The faster you go, the more pronounced this effect becomes. Years pass for the people on Earth, but for you, aboard the spaceship, only months or even days might go by. You've traveled to the stars, and as you return home, you find that decades have passed on Earth, while for you, it has only been a short period of time. Time, it turns out, is relative. It changes depending on where you are and how fast you're moving. This concept, so mind-boggling at first glance, has been proven experimentally. Scientists have measured the difference in time experienced by atomic clocks, one traveling on a high-speed plane and the other left on the ground. After the flight, the clock on the plane was found to have ticked slightly slower than the one on Earth, proof that time does, in fact, slow down with velocity. It's easy to dismiss these ideas as fantastical when we consider our everyday experience, where time feels fixed, where an hour feels like an hour, no matter where we are. But Einstein's theory tells us that time is far more dynamic than we realize. The difference in time isn't just a theoretical curiosity. It has real-world consequences, especially in the extreme environments of space. To deepen our understanding, we must introduce the concept of space-time, a unified framework that combines time and space into a single entity. Before Einstein, time and space were seen as separate, as two independent dimensions. Space was a three-dimensional expanse in which objects existed, while time was a linear progression that moved from past to future. But Einstein's theory of relativity showed us that space and time are intrinsically connected. They are part of a single fabric, space-time, and this fabric can be warped and stretched by massive objects like stars, planets, and black holes. Picture space-time as a large, stretchy sheet. If you place a heavy object like a bowling ball on the sheet, it creates a dimple, a curve that bends the fabric. This is how massive objects like stars and planets affect space-time. The more massive the object, the greater the curvature, and this warping of space-time is what we experience as gravity. But this curvature doesn't just affect space, it affects time too. In areas where space-time is warped, such as near a black hole, where gravity is incredibly strong, time slows down. Imagine a clock placed on the surface of a planet near a black hole. The closer the clock is to the black hole, the slower time would pass, relative to a clock far away from it. This is gravitational time dilation, the effect of gravity on the flow of time. In the immense gravity of a black hole, time nearly stops, frozen in a moment that can never be escaped. This brings us to another profound idea. The connection between time and space is not just theoretical, it's an intrinsic part of how the universe operates. Time does not move independently of space, it moves with it. The fabric of space-time is malleable, bending and stretching in response to objects with mass, and time itself flows differently depending on where you are within this fabric. Time isn't the same everywhere. It's warped, curved, and shaped by the forces of the universe. But if time is relative, if it bends, stretches, and dilates in different ways depending on where you are, what does this mean for our experience of reality? We are accustomed to thinking of time as a single, continuous flow, but Einstein's relativity shows us that time is not the same for everyone. It can bend, shift, and warp depending on your position in space and how fast you're moving. Time, it turns out, is not just a clock ticking away. It is a dynamic force, one that is intimately tied to the very fabric of the universe. This presents us with a challenge that Einstein himself recognized. If time is so malleable, if it flows differently in different parts of the universe, then what does this mean for our subjective experience of time? Why do we feel like time is moving forward when in reality, time could be bending and warping in ways we don't perceive? In the next phase of this journey, we'll explore these mysteries even further. We'll look at how quantum mechanics and Einstein's theory of relativity converge, and how they suggest a reality far more fluid and dynamic than we ever imagined. But for now, we have a clear understanding of one thing. Time is not what we thought it was. It is not a fixed, absolute force. It is a malleable, subjective phenomenon shaped by the very fabric of space-time itself. As we continue our journey, we'll see how the fluidity of time offers us a glimpse into the true nature of reality, a reality where the rules are far more mysterious, far more intricate than we could ever imagine. And perhaps in understanding the fluidity of time, we'll come closer to understanding the ultimate nature of the universe and our place within it. The block universe. Time as a weak dimension. Close your eyes and imagine the universe, everything you've ever known, all of reality existing at once. The stars you see tonight, the events of the past, the moments yet to come, all interwoven in a single, unchanging whole. Now imagine that this vast, infinite existence isn't something that moves forward in time. It is a block, frozen in place, where the past, present, and future coexist simultaneously. The idea that time, as we experience it, is merely a perception, an illusion of our consciousness, might seem strange at first. But what if time isn't the flowing river we have always imagined it to be? What if it's not something that passes, something that takes us from one moment to the next? What if time is, instead, like another spatial dimension existing alongside the three we know: length, width, and height? This is the essence of the block universe theory, a radical shift in our understanding of time. In this view, the entire universe, all of time, is a single, unchanging block. Everything from the birth of stars to the fall of civilizations is laid out, existing all at once, not flowing but fixed. It is a view of time that stands in stark contrast to the traditional idea of time as a river, always flowing, always moving forward. At the heart of the block universe theory lies a simple yet profound question. What if time isn't something that flows, but something that is already laid out, frozen, unchangeable, existing as part of the fabric of the universe? If time is like another dimension, then the universe is not a place where events unfold from past to present to future. Instead, all events are equally real and equally existent, contained in the fabric of space-time, already laid out in a block of existence. Think about it this way. Imagine you are walking along a path in the woods. As you walk, you experience the world unfolding before you, each step a new moment, each step a new event. You experience time flowing from past to present to future. But if time is a dimension like the other three spatial dimensions we know, The path you are walking is already laid out, fixed in its entirety. Every moment, every event, from the moment you first step on the path to the moment you reach the end, exists at once. The only reason you perceive it as flowing is because you, the observer, are moving along the path, experiencing it moment by moment. This is the block universe theory. Time is fixed, the past is just as real as the present, and the future is already there. In this view, there is no flow of time, no becoming. There is only a static reality where all events exist in a timeless, eternal dimension. Time, as we understand it, is nothing more than a human construct shaped by our consciousness, designed to help us navigate the world. This theory might sound unsettling. After all, it upends everything we've ever believed about time. If time is a block, then everything that has ever happened, is happening, and will ever happen already exists. The past, present, and future are fixed points on a timeline, interwoven in space-time. There is no becoming in the block universe. Everything simply is. Our experience of time moving forward is simply a product of our consciousness. What does this mean for free will? If the future already exists, if every moment is fixed, then what room is there for choice, for change, for the idea that we can affect the world around us? If every event is already laid out in the block, then does this mean that all our actions are predetermined? The idea that we are living in a universe where time is static raises profound questions about our place in the universe. Are we simply actors on a stage, moving along a script that was written long ago? Or do we have the power to alter the future, to break free from the fixed block of time? The implications for free will are immense. If time is like a block, if every event already exists as part of the fabric of space-time, then the choices we make are no longer free in the traditional sense. Every choice, every action may already be encoded in the block of time waiting to be experienced. There is no uncertainty, no randomness, no true becoming. Everything is fixed. We are merely experiencing the unfolding of what is already written. This view of time as a fixed block challenges our deepest beliefs about personal agency and the very nature of existence. Yet, the block universe theory does not necessarily negate free will altogether. Some have argued that while all moments may be fixed in the block of space-time, there is still a way in which we experience those moments. While the universe may be laid out in a timeless block, the experience of living, of moving along the path of time, is one of perception, one of conscious awareness. The mind, in this view, interprets time as flowing, giving the illusion of change, progress, and choice. The block of time may be fixed, but the experience of living through it is fluid, dynamic, and ever-evolving. This illusion of time's flow is central to the human experience. While the events of the universe may be fixed, our awareness of them is not. We experience time as flowing because we live in time. We cannot help but perceive it in a linear, unfolding way. Our consciousness creates the experience of movement, even if the universe itself is static. This is where the contrast between subjective experience and objective reality becomes particularly powerful. Time feels real to us, but in the grander scheme of the universe, it may not be real in the way we think. It is, instead, a perception, a creation of the mind. At the same time, the idea of a timeless block raises profound questions about the true nature of existence. If all moments past, present, and future exist at once, then what does this mean for the concept of change? Does change still exist in a universe where everything is fixed? Or is change simply another illusion? In the block universe, events don't unfold, they simply are. There is no becoming, no progression. There is only existence laid out in a static, eternal block. This idea challenges not only our understanding of time, but of existence itself. If time is an illusion, if all moments coexist in a block, then what does this mean for the nature of the universe? Is the universe simply a fixed reality, a collection of moments that are not experienced but merely perceived? And if we are part of this block, how do we fit into the larger scheme of existence? The block universe theory presents a static, unchanging view of reality, one where time does not flow, where the past, present, and future all exist simultaneously. It suggests that the universe is not to structure our existence, but what if, at the smallest scales of reality, this orderly progression of time begins to unravel? What if time doesn't behave in the clean, linear way we experience it? What if, at the quantum level, time is far more paradoxical, far more fluid than we've ever imagined? Quantum mechanics, the branch of physics that deals with the behavior of particles at the smallest scales, is a realm where time does not conform to the simple laws of the macro world. In fact, at the quantum level, time seems to break down entirely. Quantum superposition and quantum entanglement are two of the most perplexing phenomena in this strange world, and they reveal just how paradoxical time can be. First, let's dive into quantum superposition, a concept that defies our classical understanding of time. In the quantum world, particles do not exist in one definite state at any given moment. Instead, they exist in a superposition of states where they can be in multiple places or states at once, each one with a certain probability. A single particle, for instance, might be simultaneously in two places at the same time, or it could be spinning in two opposite directions simultaneously. But here's the most mind-bending part: this paradoxical state of multiple possibilities exists simultaneously. Only when we observe the particle does it collapse into a single state, choosing one possibility and seemingly choosing a definite moment in time. This phenomenon shatters the classical understanding of time as something that flows. Into the quantum world, time does not seem to have the same forward momentum we feel in our daily lives. Instead, events exist in a blurred state of potentialities, as though time itself is suspended, awaiting the intervention of the observer to force a definitive choice. Imagine a quantum coin flip. A coin spinning in the air, it exists in a state of superposition, both heads and tails at once, until it lands. But unlike the everyday world where a coin must land in one state, in quantum mechanics, the coin is both heads and tails simultaneously while it's spinning. It's only when you catch it, when you observe it, that it decides what it is. This means, in a sense, time is not defined by its progression through moments, but rather by the observer's interaction with the system. Time is not an independent, linear sequence, but is deeply entangled with the act of observation, creating a strange, unpredictable quality to the unfolding of events. As if quantum superposition wasn't strange enough, we then encounter quantum entanglement, which further complicates the role of time in the quantum world. Entanglement occurs when two particles become linked in such a way that the state of one particle instantly influences the state of the other, no matter how far apart they are. Imagine two particles that are light years apart. Even though they are separated by vast distances, a change in the state of one particle will instantaneously affect the state of the other particle. This spooky action at a distance, as Einstein famously described it, happens faster than the speed of light, and suggests that, in the quantum world, time and space do not operate as we have been taught to understand them. In a universe governed by relativity and classical physics, nothing can travel faster than light. Time and space are intertwined. Traveling at speeds close to the speed of light can warp the passage of time itself, as we explored in Einstein's theory of relativity. But in quantum mechanics, entangled particles seem to transcend these rules. They communicate instantaneously, ignoring the usual limits imposed by the speed of light. This raises an unsettling question. Does time even apply in the same way to these particles? How can these particles be linked without any regard for the distance between them, let alone the time it takes for information to travel. In a sense, quantum mechanics presents us with a vision of time that is non-linear and uncertain, a universe where time doesn't flow in a clear direction. In the quantum world, the past, present, and future blur into a chaotic web of possibilities. Quantum entanglement challenges the assumption that time is the medium in which cause and effect unfold, revealing that in the quantum world, events seem to happen simultaneously, even across vast distances. The usual flow of time where one moment leads to the next is not always respected in this strange realm. This creates an enormous disconnect between the macroscopic world, the world we experience every day, and the microscopic world of quantum mechanics. In the classical, everyday world, we perceive time as moving forward, the future unfolding from the present, and the present shaped by the past. But in quantum mechanics, this flow is not a given. The rules of time are uncertain, flexible, and paradoxical. The classical view of time as a straight, unbroken line that carries us forward from one moment to the next is shattered by quantum mechanics, where time behaves unpredictably and particles exist in states that defy the usual rules of cause and effect. This paradox leads us to one of the most fascinating questions of modern physics. How does time exist in a universe where its flow is not uniform and linear? The idea that time might not behave in the way we experience it challenges our very conception of reality. How can something so fundamental to our existence, the passage of time, be so fluid, elusive, and uncertain at the quantum level? How can we reconcile this chaotic, uncertain behavior of time with our everyday experience of time as something predictable, measurable, and continuous? One possibility is that our experience of time is a consequence of our macroscopic scale. Our consciousness, our sensory experience, is designed to navigate a world where time seems linear and continuous. But as we zoom in on the quantum world, we find that this intuitive experience of time begins to break down, replaced by a more complex and fluid set of rules. The behavior of quantum particles might be independent of time's flow as we know it. They exist in a state of superposition and entanglement that does not rely on a linear progression of past to future. Instead, time is something that seems to unfold only when observed, giving us a very different experience of reality than what we feel in our everyday lives. As we explore the paradoxical nature of time in quantum mechanics, we find ourselves confronting the very limits of our understanding. Time, it seems, is not the simple, linear progression we've always assumed it to be. It is a phenomenon that behaves in unpredictable, strange ways at the quantum level, raising profound questions about how time operates and how we experience it. And just as the quantum world forces us to confront the fluidity and uncertainty of time, it also compels us to question the very nature of reality itself. As we explore the paradoxical nature of time in quantum mechanics, we find ourselves confronting the very limits of our understanding. Time, it seems, is not the simple, linear progression we've always assumed it to be. It is a phenomenon that behaves in unpredictable, strange ways at the quantum level, raising profound questions about how time operates and how we experience it. And just as the quantum world forces us to confront the fluidity and uncertainty of time, it also compels us to question the very nature of reality itself. So where does this leave us? We've seen that time in the quantum world is far from predictable. Particles don't always behave according to our expectations of time and causality. Time may be more elusive, more dynamic than we ever imagined. And perhaps, in understanding the true nature of time at the quantum level, we can begin to glimpse a deeper, more mysterious universe, one where the rules of time are far from what we experience, and where the flow of time itself may be an illusion. The eternal now. Does the present moment exist? Close your eyes, take a deep breath, feel the air fill your lungs, the present moment stretching infinitely around you. Now let the thought settle in. What if this moment, this breath, this heartbeat is the only thing that truly exists? The past is a memory, a collection of fleeting moments that have already faded into the distance, inaccessible except in the recesses of our minds. The future? It's a dream, a possibility yet to unfold, a series of unknown events that we can never truly know until they arrive. But the present, this fleeting moment, is all we really have, and yet we rush through it, always looking ahead or looking back, never fully grounding ourselves in the eternal now. What if this now is the only true moment in existence? What if the past and the future are nothing but constructs of our minds, projections of memory and possibility? Could it be that time itself doesn't flow as we've always assumed, but that only the present moment truly exists? The past and future, in this view, are illusions, products of our perception, not objective features of reality. Welcome to the world of presentism, the philosophical theory that posits that only the present moment is real. According to presentism, time does not flow from past to future in the way we experience it. Instead, the only moment that truly exists is the present. Every other moment, whether past or future, is merely a mental abstraction, a story we tell ourselves. In this view, time does not move forward. It is always a timeless now that is continuously experienced by consciousness. In our daily lives, we think of time as a river, with the past receding behind us and the future rushing ahead, always one step out of reach. But the present moment is constantly slipping away, evading our grasp, and we are left with the ever-present illusion of time's passage. The moment we experience as now is fleeting, vanishing as quickly as it arrives. Does that mean it's real? Or does it exist only because we perceive it to be so, as we construct the now in our minds? To understand this deeper, let's look at the scientific lens. In the theory of relativity, time and space are part of a unified fabric called space-time. But this fabric is not static, it is malleable, shifting depending on the observer's frame of reference. Time dilation, for example, tells us that time doesn't flow equally for all observers. It bends and stretches depending on the observer's velocity or proximity to a massive object, like a planet or star. In the vast expanse of the cosmos, time does not flow the same way for everyone. It is relative, not absolute. However, relativity also gives us a different perspective. Space-time is a four-dimensional continuum where the past, present, and future are not distinct and separate, but all part of the same continuum. In relativity, the past is just as real as the present. The future is no less real than the present moment. This view is often referred to as the block universe, where time is a frozen block. The past, present, and future coexist simultaneously, and the flow of time is an illusion created by our perception. But this doesn't sit well with our intuitive experience of time. We feel the present as an unfolding moment, a snapshot in a continual stream of events. We sense time moving, ticking forward, and we act accordingly, moving through life as if the future will come to be, and the past is something to reflect on. In this sense, time feels like a flowing river, a constant progression from one moment to the next. Yet as we dive deeper into the quantum realm, even the notion of now becomes more elusive. In quantum mechanics, particles do not occupy a definite position until observed. They exist in a superposition of states, which means that, at least until measurement, they can be in multiple places at once. There is no single moment in time in the quantum world. Particles are not bound by a clear, linear timeline. Their states exist in probabilities, not certainties. Here's the twist. If the now is so fluid in the quantum world, so uncertain, then what does that say about our perception of time in our everyday experience? Could it be that the present moment, the one we hold on to so tightly, is similarly illusory? The more we understand about the fundamental nature of reality, the more we realize that our perception of time as a constant, linear flow is not mirrored by the universe itself. The challenge here is this: how do we reconcile our lived experience with the scientific theories that seem to suggest a very different view of reality? The sensation of time's passage, the feeling of past, present, and future, is it a feature of consciousness alone, a construction we create to give order and meaning to our lives? Or is there something real about the now, something tangible that exists despite the paradoxes science throws at us? One of the key philosophical implications of presentism is that the past and future do not exist except as concepts. The past is a memory, something we reconstruct from the present moment. The future is a projection, a possibility, and while it is often shaped by the present, it is no more real than a dream. In this view, the universe is not unfolding through time. It is already fully laid out, with each moment existing in its own timeless now, only perceived by conscious beings as a flow. But presentism, with its emphasis on the now, also challenges our concept of free will. If time is not flowing from past to future, if everything exists in a timeless block, does that mean that our choices, our actions are already fixed in time? Are we simply experiencing a timeline, one that already exists, rather than creating it as we go? This idea suggests that what we think of as free will might be just another illusion, an experience our consciousness creates to make sense of the block-like nature of time. Yet how do we experience time? While science might suggest that time is an illusion, we still live as though each moment is real. We experience change, we experience the passage of time, and we perceive ourselves moving forward through life. The eternal now might be a philosophical ideal, but it doesn't erase the fact that we live in a world where time feels like it's constantly in motion. Could it be that we are living within an illusion of time where only the present exists, and everything else is a mental construct, a product of our consciousness? Could the past and future be nothing more than stories we tell ourselves, ways for our minds to organize our experience, but not part of the reality we inhabit? The eternal now challenges us to think about time in a radically different way. It forces us to consider whether the present moment, the one we experience and perceive, is not just a fleeting instant, but the only real moment that truly exists. As we continue exploring the nature of time, we'll see that the eternal now is just one part of the larger puzzle. Time, we'll find, is not just a linear progression, but a dynamic and elusive concept intertwined with consciousness and the structure of the universe itself. But to understand the present moment, we must also grapple with the past and future, and in doing so, we may uncover a deeper understanding of the nature of time and of our place in it. Time and consciousness. Does awareness shape time? It slips through our fingers, unstoppable, but do we truly experience it the same way at all times? Have you ever found yourself in a moment so absorbed in the present that time seems to stretch indefinitely? Or conversely, caught in a moment of dread or anticipation, where time feels like it drips by, slowly or worse, seems to come to a halt? What is it that allows time to feel so fluid, so malleable in those moments? Is it the nature of time itself, or could it be our consciousness, our awareness, that shapes how we experience the flow of time? Time is both a physical phenomenon and a deeply psychological experience, and the tension between these two dimensions is where we begin our investigation. We measure time through clocks, and physics provides us with equations that describe its passage. But in our daily lives, time feels anything but mechanical. It feels personal, subject to the pull of our emotions, thoughts, and attention. As we delve into the intersection of time and consciousness, we confront a fascinating question. Is the flow of time something that happens to us, or is it something our mind shapes? This section takes us to the heart of a phenomenon known as psychological time, a concept that describes how time is not only an external fixed process, but also a subjective experience shaped by attention, emotion, and memory. While physics may tell us that time is a constant, ticking forward in seconds, minutes, and hours, our personal experience of time can be drastically different. Time speeds up, slows down, or even appears to stop entirely depending on how we experience it. Could it be that time, at its core, is as much a construct of the mind as it is a physical reality? Consider for a moment how time can slow down or speed up based on your emotional state. Think of an adrenaline-pumping experience. Perhaps you've been in a car accident, or you've been in a high-stakes situation where every second feels like an eternity. This is a classic example of time dilation, but not the kind we learned about in Einstein's theory of relativity. No, in these moments, time does not slow down due to velocity or gravity, but due to the way our mind processes information. In times of stress or excitement, our consciousness becomes more aware, absorbing every detail with an almost obsessive intensity. The increased focus on the present moment distorts our perception of time, making it feel as though it has stretched. In contrast, think about how quickly time passes when you're distracted or uninterested. When you're enjoying a conversation or engrossed in a project you love, hours can pass in what feels like a blink of an eye. Yet, when we're bored or waiting for something, time crawls. It's a curious paradox. When we're deeply engaged in the present, time seems to pass quickly, but when we're restless or anxious, time feels like it's dragging on forever. What's happening here? How is it that we can feel time move differently based on our state of mind? This contrast between subjective time, how time feels to us, and objective time, the ticking of a clock, the movement of hands around a dial, is a puzzle at the intersection of psychology and physics. How is it that time, a concept we think of as constant, can feel so different from moment to moment? Can we truly say that time is a simple, measurable phenomenon if our experience of it is so inherently flexible? The answer, at least in part, lies in the way our brain perceives and processes time. Our sense of time is deeply tied to attention and memory. When we are more focused, we are more aware of each passing moment, causing us to remember it more vividly. This intensity of experience gives us the impression that time is slow or long-lasting, even though the actual passage of time is no different. On the other hand, when our attention is scattered or when we're distracted, we don't notice time as acutely and it seems to pass faster. The mind's perception of time depends on how deeply we are engaged with the present moment. In psychological studies, time perception is often tied to cognitive load. The more cognitive effort we expend, the more deeply we are immersed in a task, the more time feels elongated. In contrast, when we are not paying attention, when we're simply going through the motions, time tends to feel like it's flying by. But how does this all connect with the physical nature of time, the laws of physics, where time is constant and predictable, independent of human experience? The dissonance between these two perspectives is striking. If time is truly a fixed physical quantity, then how is it that consciousness, our perception, can seem to shape it so profoundly? This takes us to one of the most fascinating implications of our investigation. Could it be that our consciousness is not just an observer of time, but a creator of it? What if time, as we experience it, is not simply a progression that exists outside of us, but is instead something our minds construct in real time? What if time doesn't exist independently in the universe, but instead emerges from how our consciousness organizes reality? Consider the implications of the eternal now, the concept that only the present truly exists and that the past and future are nothing but constructs of memory and anticipation. If we think of time not as a river flowing but as a mental construct, could it be that we are constantly creating time as we move through life? The act of awareness, of living in the moment, may shape our perception of the past, our memory of it, and our anticipation of the future. These are all constructs, mental stories we tell ourselves about how time has passed or how it will unfold. The present moment might be the only real experience we have, as everything else exists in memory or expectation. If this is true, then our experience of time, the way it stretches, the way it slows down or speeds up, is deeply connected to our awareness and our consciousness. Time, in this sense, is not a physical phenomenon that exists outside of us. It's something we create. Through the act of perception, this idea challenges the classical view of time. Could the flow of time, this seemingly fundamental force that structures the universe, be a construct of the mind as much as it is a physical phenomenon? Could it be that our experience of time moving forward is more about the narrative we create in our minds than about the movement of objects through space? This theory has profound implications for how we understand the passage of time. If our experience of time is constructed, then perhaps time is more malleable than we've ever realized. Could we, in theory, change the way we experience time? By changing how we relate to the present moment, how we engage with it? Could we, through mindfulness or awareness, alter the subjective experience of time itself? As we continue our exploration, we'll dive into more scientific and philosophical perspectives that push the boundaries of our understanding. Time, it turns out, might be far more mysterious and far more personal than we ever imagined. And, as we peel back the layers of perception, we may just find that time is not just a physical reality, but a mental construct, shaped and molded by the consciousness that experiences it. The arrow of time. Why does time move forward? Time, for all its mystery, feels like one of the few things we can rely on in this world. It moves unceasingly, relentlessly forward. From the moment we are born, we are swept along in its current. Days pass into weeks, years into decades, and with each passing moment we grow older. The world around us changes and history marches on. Time feels like a straight line, an arrow fired from the past, racing toward the future, unidirectional, irreversible. But what if this feeling, the ticking clock that orders our lives, what if this sense of time flowing forward is not as fundamental to the universe as we believe? Why does time move forward? This is the question at the heart of what physicists and philosophers call the arrow of time. The arrow of time is the idea that time has a direction, an inherent flow from the past to the future. It's a natural feature of our universe, or so we've thought. But as we look deeper into the laws of physics, we uncover a startling truth. Time might not have to move forward at all. Time, it turns out, might be a far more mysterious and contingent force than we ever imagined. The simplest and most familiar explanation for why time moves forward lies in the second law of thermodynamics, one of the most fundamental principles of physics. The second law states that in any closed system, the amount of entropy or disorder tends to increase over time. As entropy increases, systems become more disordered, less predictable, and more complex. This increase in entropy provides a natural direction for time from less ordered states in the past to more ordered, disordered, or chaotic states in the future. Essentially, entropy increases as time progresses, and the universe's state becomes more chaotic with each passing moment. This steady rise in disorder gives time its arrow moving in one direction toward greater disorder. In everyday life, this idea of entropy is easy to see. Think of a glass of ice water. When the ice melts, it loses energy, and the system becomes more disordered, with the cold water mixing with the warm. The reverse doesn't happen naturally. You cannot unmelt the ice without inputting additional energy. Entropy rises as ice melts, water warms, and the system becomes more disordered. This increase in disorder gives time a direction. Time moves forward because things naturally become more chaotic. But while the second law of thermodynamics gives us a compelling explanation for the unidirectional flow of time, it doesn't provide the full story. In fact, there are other forces at play that seem to undermine the very idea of time having a single, fixed direction. At the cosmological level, we know that the universe has a beginning, the Big Bang. The birth of the universe marked the beginning of time itself, an event that set the arrow of time in motion. From the Big Bang, the universe expanded, cooling and evolving, with galaxies, stars, and planets forming as entropy increased. The beginning of the universe gives us a clear starting point for the flow of time. But what about the end? Can we ever be sure that time always flows forward, or is there a possibility that it could go in reverse? Some cosmologists have proposed the idea that, in the distant future, the universe might contract rather than expand, leading to a big crunch where time could flow backward, leading everything to collapse in on itself, reversing the arrow of time. This idea challenges our intuition and raises an intriguing question. Is the flow of time a fundamental feature of the universe, or is it a product of the way we experience it? If time's arrow is tied to the increase of entropy, then is time itself just a reflection of the universe's tendency toward disorder, something that could potentially reverse in the right circumstances? Now let's dive deeper into quantum mechanics, a realm where time behaves even more paradoxically. At the quantum level, particles exist in states of superposition. They can be in multiple places or states at once, their exact position and momentum only becoming definite when measured. This quantum indeterminacy suggests that in the microscopic world, time might not be as absolute as we believe. Could it be that at the quantum level, time could actually move backward or be reversed? Some speculative theories suggest that quantum entanglement, the phenomenon where two particles become instantaneously linked regardless of distance, hints at a deeper, more complex relationship between time and space, one that could allow for reversible time. In fact, quantum mechanics doesn't require time to flow in a particular direction. Some equations of quantum mechanics are time-symmetric, meaning they work just as well if time flows backward as they do when it flows forward. In the quantum world, there is no fundamental directionality of time. This starkly contrasts with our macroscopic experience of time, where we cannot uncook an egg or reverse the aging process. But in quantum mechanics, the symmetry of time suggests that time could be reversible, an idea that challenges the very concept of time as an arrow moving forward. So, if time could, theoretically, move backward in the quantum realm, why does it seem to flow in one direction in our everyday experience? The answer may lie in our perception of time, the way our consciousness experiences the passage of time. While physics offers a theoretical possibility for time to run backward, our consciousness and experience of time are tightly bound to the directionality of entropy. Our subjective experience of time is inherently tied to the increase in disorder, the arrow of time. And even though we know time might not always be as it seems at the quantum level, we experience it as moving forward, from past to present to future, because our minds are wired to organize experience in a linear fashion. This dissonance between the macroscopic flow of time and the more fluid, reversible possibilities suggested by quantum theory creates a tension in how we understand time. Is the arrow of time a fundamental property of the universe dictated by the increase of entropy, or is it an illusion shaped by our subjective perception and the laws of physics that govern the universe at larger scales? Philosophically, this tension between the classical thermodynamic view of time and the quantum possibility of reversible time raises important questions. Could time's flow be nothing more than a mental construct, an illusion our consciousness creates to make sense of a universe that on deeper levels may not have any true fixed direction? In a world where time seems to stretch, contract, and bend, where could the flow of time take us if we looked at it from another angle, one that is not bound by the laws of entropy? As we continue exploring time's paradoxical nature, we are left with a profound mystery. Is the arrow of time a real, unchanging feature of the universe, or is it just an illusion, a product of our limited experience of time? And if time is indeed an illusion, what does that say about the nature of existence itself? Is time merely a tool for organizing our perception, or is it a fundamental force that dictates how reality unfolds? Time in the quantum vacuum, a deeper mystery. Imagine a place where nothing exists. No stars, no galaxies, no planets, no light.
No sound, a vast expanse of nothingness. Yet even in this emptiness, something strange is happening.
Particles are popping in and out of existence, emerging from the void only to disappear again in the blink of an eye. These particles, though transient and fleeting, are real. They can be measured, they affect the world around them, and yet they exist in timeless moments, moments that defy our classical understanding of time. This place, the so-called quantum vacuum, is one of the most mysterious corners of reality. It's often described as empty space, a void where no matter, no energy, and no classical time should exist. But in the quantum world, even this nothingness is alive with activity. The quantum vacuum is anything but empty. It is a seething, fluctuating field of potentialities, a place where particles briefly come into being and then vanish, only to be replaced by others, in a constant dance of creation and annihilation. But here's the problem. In this vacuum, time behaves differently than what we experience in our everyday world. In the quantum vacuum, the usual flow of time seems to break down. Particles don't exist in a fixed timeline moving from past to future as we do. Instead, they seem to emerge and disappear outside the normal constraints of time. In this strange realm, we are forced to ask, does time even exist at the quantum level? Or is it something we impose on reality? To explore this, we must first understand the nature of quantum fields, the fundamental fabric of the universe at the smallest scales. According to quantum field theory, the entire universe is filled with fields that permeate all of space. These fields are not static, they vibrate, fluctuating in and out of different states. What we think of as particles, electrons, photons, quarks are ripples or excitations in these underlying quantum fields. In essence, particles are just temporary disturbances in these fields, popping in and out of existence as the fields fluctuate. But what's fascinating is that these fluctuations don't adhere to our usual understanding of time. In the classical world, time is a continuous, unbroken flow from past to present to future. But in the quantum vacuum, this flow seems to be disrupted. When a particle appears in the quantum vacuum, it doesn't exist in a specific time, it simply emerges as part of a quantum fluctuation, a fleeting disturbance in the field. It's here for a moment, then gone, but during that moment it still has an effect. It interacts with its surroundings, despite having no clear, linear relationship to time. Think of it this way. Imagine a pond with calm water. If you throw a stone in the pond, you'll see ripples spreading out in a predictable way, moving outward in time. In the quantum vacuum, imagine instead that the ripples appear and vanish without any clear pattern or cause. It's not that the ripples are moving forward through time, they are simply fluctuations that happen in timeless moments, moments that are detached from the usual flow of past, present, and future. This raises an important question. Is time a fundamental feature of the quantum vacuum, or is it a construct that emerges only at larger scales like the scale of our everyday reality? In the quantum world, time seems to lose its conventional meaning. Particles can exist without moving. Through time as we know it, they can appear, interact, and disappear, all in a seemingly timeless instant. What does this say about the nature of time? If time is a construct of our larger reality, if it is something we impose on the universe to make sense of the world, then perhaps time is not as fundamental as we think. Could it be that at the deepest levels of reality, the level of quantum fields and the vacuum time does not exist at all? In fact, some physicists and philosophers have speculated that the quantum vacuum might exist outside the usual boundaries of time altogether. This idea challenges our most basic assumptions about the nature of reality. If time doesn't exist in the quantum vacuum, then what does that mean for our experience of time? Does time, as we understand it, emerge only when we interact with the physical world? Is it a feature of consciousness, something we create to organize our experience rather than something that inherently exists in the universe? To dig deeper, consider the concept of virtual particles, which are particles that momentarily appear and then vanish in the quantum vacuum. These particles don't have a fixed existence. They exist for infinitesimally short moments, far too brief for us to measure their position or momentum. They pop into and out of existence as if they are not bound by time. These virtual particles are often described as borrowing energy from the vacuum before they vanish again. But how can something borrow energy if it doesn't exist in a specific moment of time? This suggests that in the quantum vacuum, time may be a non-existent or optional feature, something that only emerges when energy is exchanged or when we observe the universe at larger scales. This idea isn't just speculative. It challenges our understanding of reality itself. Could it be that time is something that arises only from the complex interactions of quantum fields? Could it be that time is a product of consciousness, or the way we observe and interact with the world, rather than an absolute, fundamental aspect
of the universe? Now let's take this a step further. The quantum vacuum is often described as the ground state of the universe, essentially the lowest possible energy state.
It is nothing, yet it is teeming with activity, with fluctuations that create particles and fields. These fluctuations occur outside of time as we understand it. Particles emerge from nowhere and disappear back into nothingness. The quantum vacuum doesn't experience time the way we do. Instead, it exists in a timeless state, full of potential but devoid of the passage of time. This timelessness raises a provocative possibility. If time is a feature of our perception, something that arises only when we engage with the larger, observable world, then could it be that the true nature of reality is beyond time altogether? Could the quantum vacuum, this realm of fleeting particles and waves, be a realm where time itself ceases to exist, a timeless ground where the universe itself is born and reborn, not bound by past or future? As we peer into the mysteries of the quantum vacuum, we realize that the idea of time is more elusive and complex than we ever imagined. In the vacuum, time seems to be non-existent, or at least not a fundamental feature of the universe. Time might be a construct, emerging from the behavior of quantum fields and consciousness, rather than a force that shapes the very fabric of reality. This raises deep philosophical questions. If time doesn't exist in the quantum vacuum, does time exist at all? And if time is merely a construct, then what does this mean for our understanding of the universe and our place in it? As we continue exploring the quantum world, we'll see that time, in its most basic form, may be far more fluid, elusive, and mysterious than we've ever realized. The quantum vacuum shows us that the true nature of time might not be bound to the flow of seconds, minutes, and hours, but to something deeper, something beyond our ability to measure or define. And perhaps in understanding this deeper mystery, we can begin to understand reality itself, a reality that may not be bound by time at all. time and the cosmos, the beginning and end of time. Imagine, for a moment, a time before time existed, a universe with no past, no present, no future, nothing but infinite potential. No clocks ticking, no stars burning, no planets forming, just emptiness. And then, from this void, something extraordinary happened. The Big Bang, the event that gave birth to time itself. The Big Bang isn't just the birth of the universe, it's the birth of time. Before this moment, time didn't exist as we understand it. There was no before, no after. The concept of time only came into being when the universe expanded from an infinitely dense point, sending waves of space and time rippling out in every direction. This moment, this origin of time, marks the beginning of everything we know, from the galaxies to the stars to the very seconds that tick by on a clock. But just as time had a beginning, it also has an end. How could something as fundamental to our existence as time have an end? We are accustomed to thinking of time as continuous, a river flowing eternally from past to future. But in the vastness of the cosmos, time's flow is anything but certain. From the birth of the universe, through its expansion to its potential demise, time exists in a delicate balance, one that might very well come to a stop. The Big Bang, the birth of time. The Big Bang theory is the prevailing cosmological model that describes the origin of our universe. Around 13.8 billion years ago, the universe began as a singularity, a point of infinite density and temperature where both space and time were compressed into a single point. The laws of physics, as we understand them, break down in such extreme conditions, and the very fabric of space-time itself was created in this moment. It's almost impossible for us to imagine such an event, a universe created from nothing. But as the universe began to expand, so did time itself. Space and time, once inseparable, began to stretch and unfold. The universe didn't just expand outward in space, it also expanded time. The ticking of time as we know it began in this moment, as the universe stretched and cooled, allowing the formation of galaxies, stars, and eventually the very clocks that would measure the flow of time. For nearly a century, physicists have used this concept of the Big Bang to chart the origin of the universe and, by extension, the origin of time. But this raises an intriguing question. What happened before the Big Bang? Was there a time before time? This is a question that has baffled scientists and philosophers alike. According to general relativity, time is bound to the fabric of space. Without space, there would be no time. So, in a sense, the Big Bang marks the beginning of both space and time, leaving us with no clear concept of what might have come before. The heat death, the end of time. If the Big Bang marks the beginning of time, then what might mark its end? One possibility, based on our current understanding of the universe's expansion, is known as the heat death. The heat death theory suggests that over the course of billions of years, the universe will continue to expand, gradually cooling down as stars burn out and galaxies move further apart. As the universe becomes colder and emptier, it will eventually reach a state of maximum entropy, where all energy is evenly distributed and no more work can be done. In this state, time, as we experience it, might come to an end. With no thermodynamic processes to distinguish one moment from the next, there would be no meaningful now, only a frozen, uniform, and unchanging universe. The heat death theory suggests that the universe will ultimately reach a state of stasis, where time itself becomes irrelevant, as everything is in a state of perfect equilibrium. The expansion of the universe, which began with the Big Bang, would ultimately lead to an eternal, frozen now, where the passage of time no longer holds any meaning. The cyclical universe, the Big Crunch, and the Big Bounce. But there are other theories that suggest a different fate for time. Some cosmologists speculate that time might not have a single linear direction at all. Instead, it could be part of a cyclical process, one where the universe expands, collapses, and restarts in an infinite loop. These models are known as the Big Crunch and the Big Bounce. The Big Crunch theory proposes that the expansion of the universe, driven by the Big Bang, could eventually slow down and reverse, causing everything to collapse back into a singularity, a point of infinite density and heat. Much like the state before the Big Bang, this collapse would bring everything in the universe, including time itself, to an end. But from this singularity, a new Big Bang could occur, starting the cycle all over again. In this model, time is not linear, but cyclical. It loops back on itself, forever repeating in an eternal cycle of birth, death, and rebirth. The Big Bounce theory is a more speculative variation of the Big Crunch. Instead of a complete collapse, the universe would bounce back from its contracted state, restarting the cycle of expansion and cooling. In this view, the universe does not die, it rebounds, and time continues, though in a new cycle. Both of these models suggest that the end of time could be just the beginning of another cycle, an endless loop of creation and destruction, where time itself is part of an eternal cycle. Time's purpose, a philosophical exploration. The scientific theories about the beginning and end of time provide us with a cosmic view of time's birth and possible death. But they also raise profound philosophical questions about the purpose and meaning of time. Why does time exist at all? Why should there be a beginning and an end to time? Some philosophers argue that time is a necessary component of change. Without time, there would be no motion, no growth, no transformation. In this sense, time might be essential to the nature of existence itself, the fabric that allows for change, experience, and awareness. Without time, we could not have the world we know, where moments unfold into each other in a seamless flow. Time may not have a purpose beyond its role in enabling change and experience, but this in itself gives it a profound meaning. Others, however, suggest that time's purpose might be illusory. Some philosophical traditions, such as those in Eastern thought, propose that time is a construct of the mind, an artifact of consciousness, rather than a fundamental feature of reality. From this perspective, the beginning and end of time might be human inventions, ways for us to make sense of our lives in the face of an eternal, timeless reality that transcends time altogether. In this view, time might not have any inherent purpose. It is simply a mental framework we impose on the cosmos to help us navigate the unfolding of our experiences. Awe and reflection. As we contemplate the birth and death of time, we are left with a sense of awe at the vastness of the cosmos
and the impermanence of existence.
Whether the universe ends in a heat death, collapses in a big crunch, or rebounds in a big bounce, time, this force that governs so much of our experience, will ultimately come to an end in one form or another. And yet we can't help but wonder, is time itself just a way for us to perceive change? Is it a cosmic illusion, a reflection of our limited consciousness in a universe that is far more timeless than we ever imagined? In the end, the beginning and end of time raise one of the most profound mysteries of existence. If time is finite, if it has both a start and an end, what does that mean for our place in the universe? Are we simply passing through a fleeting moment in a grand cosmic cycle? Or is time in the end just another illusion, a construct of consciousness created to make sense of a reality that exists outside time altogether? Can we experience time beyond time? Time is often considered the great ruler of our lives. It moves us from one moment to the next, shaping our experience of reality. We live in its constant flow and we measure every second, every minute, every year. But what if time, this unyielding force that governs our very existence, is not the final authority on consciousness? What if the mind, our awareness, could transcend time itself? Imagine for a moment being free of time. The familiar ticking of the clock stops. The future doesn't pull at you and the past doesn't weigh you down. Instead, you exist in a timeless moment, one that stretches out in an infinite now. Your consciousness isn't bound by time's linear flow, but exists in a state where time doesn't exist at all. Could such a state be possible? Could human consciousness exist outside of time's constraints, experiencing life not as a constant progression from past to present to future, but as an eternal now? This is the concept of timeless consciousness, the idea that the mind, or perhaps the true self, is not bound by the physical passage of time. Mystical and philosophical perspectives. The eternal now. This idea has been explored by mystical traditions and philosophers for centuries. Many mystics, from ancient Hindu and Buddhist traditions to modern spiritual thinkers, have posited that our normal perception of time is an illusion, a limitation of the material body and the mind's connection to it. According to these perspectives, the true self, the eternal consciousness, exists outside of time. The experience of time, they argue, is an aspect of the physical world, but consciousness itself is timeless, existing in an eternal present. In Hindu philosophy, the concept of the Atman, the true self, is often described as eternal, beyond the cycle of birth and death, beyond time itself. In the state of moksha, or enlightenment, one is said to experience a timeless reality, where the illusion of time is dissolved. The mind, freed from the constraints of time, enters a state of pure being, a timeless now that exists beyond space and time. Similarly, in Buddhism, the concept of nirvana is described as a state of liberation from the cycle of suffering and rebirth. In nirvana, time itself ceases to have meaning. The individual self is transcended, and what remains is an experience of pure consciousness, timeless, eternal, and beyond the limitations of physical existence. These mystical traditions suggest that time is not an inherent feature of consciousness. Instead, time is something that the mind creates to navigate the material world. Beyond time, the mind is free from the constraints of the physical body, experiencing a continuous present, an eternal now. Time and the mind. But what do the scientific theories say? Can consciousness really exist outside of time, or is it inextricably linked to the physical body and the passage of time? In the world of neuroscience and physics, the relationship between consciousness and time is still one of the most profound mysteries. From a neurological perspective, the human brain processes time in very real ways. We have internal clocks that measure the passage of time, and our experience of the world is largely shaped by these processes. Our senses of memory, anticipation, and awareness are all tied to time. Our mind processes the past, plans for the future, and organizes the present in relation to both. In this view, consciousness is something that is directly bound to the flow of time. Without time, there is no conscious experience, at least, not in the way we understand it. However, quantum mechanics introduces a different perspective on time and consciousness. At the quantum level, time is not as rigid as we experience it. As we've explored in previous sections, time behaves very differently in the quantum vacuum, where particles can appear and disappear without a clear connection to time. In some quantum interpretations, such as the many worlds theory, every possible state of the universe exists in parallel, and time may not be a linear progression, but a branching tree of possibilities. In quantum field theory, consciousness is often seen as a product of the brain's interaction with the quantum fields that permeate the universe. Some theories suggest that the mind, as a quantum system, may not be strictly bound by the linear flow of time. Instead, it could be capable of existing in a more fluid state where the usual rules of causality and temporal progression are more flexible. In this sense, the mind might have the potential to transcend time in a way that our everyday experience
of time does not allow. Is time a limitation of the material world?
But there is another more speculative possibility to consider. Is time a limitation of the material body? Could it be that time, as we understand it, is not a fundamental property of consciousness, but rather a constraint of our physical existence? After all, the very act of being born and dying is a marker of time. The body ages, experiences decay, and eventually returns to the earth. The body is bound by time, but is that the same for the mind? Some thinkers have proposed that the true self, or higher consciousness, might exist outside of the limitations of the physical body. The mind, in this view, is not inherently bound by time, but instead experiences time only through the body's senses. The material world with its physical constraints creates the illusion of linear time, but the true self, the consciousness that experiences life, may exist in an eternal, now unaffected by the passage of time. This idea raises profound questions about the nature of consciousness and the connection between mind and body. If the mind can transcend the constraints of the material world, what does that say about the nature of existence itself? Could it be that time is a product of the body's limitations, a way for us to navigate the physical world, but not a feature of the mind's true nature? Timeless consciousness and the universe. Finally, what does the possibility of timeless consciousness tell us about the universe itself? If the mind can experience a state beyond time, does that mean that the universe itself is somehow timeless? Is time merely a framework that organizes our experiences in the physical world, but not a true feature of reality? Could the universe, in its deepest essence, exist in a timeless now? And are we simply perceiving it through the limitations of our time-bound consciousness? Some physicists suggest that the universe, at its most fundamental level, operates beyond the usual rules of time. In quantum mechanics, particles behave in ways that defy our traditional understanding of cause and effect. Some interpretations of quantum physics suggest that time is not fundamental, but is rather a consequence of our perception of the world. If this is true, then the timeless nature of consciousness might reflect the deeper truth of the universe itself, the timeless reality behind the appearance of time. Consciousness beyond time. Could it be that as we evolve, our consciousness might one day be able to transcend the linear flow of time? Could future technologies or spiritual practices unlock our ability to experience existence outside of time? This is a speculative question, one that blends the boundaries of science, spirituality, and philosophy. Yet it points to a profound possibility that time, as we experience it, might not be the ultimate reality. Perhaps in the same way we once believed the Earth was flat, we are only beginning to glimpse the true nature of consciousness, a nature that exists beyond the constraints of time. In the end, the possibility of timeless consciousness challenges everything we think we know about time. It invites us to consider that time as we experience it is not the end of the story, it's just one layer of the complex, multifaceted reality we inhabit. If we can learn to expand our awareness, perhaps we can begin to access something even greater, a timeless truth about the nature of existence, one that is not bound by time, but by something far more profound. The timeless mystery of reality. As we stand at the precipice of this journey, looking back at the vastness we've explored, we are left with one resounding question. Does time really exist, or is it simply an illusion? Is it a fundamental feature of the universe, carved into the very fabric of space, or is it a construct created by our minds to navigate the seemingly endless ocean of experience? We began with the simple idea of time, something we measure, something we experience in a straight, linear fashion. But what if this understanding, this fundamental assumption is wrong? What if time is not the constant we believe it to be? From Einstein's relativity, where time is fluid, warped and stretched by speed and gravity, to the quantum world, where time breaks down into strange, unpredictable fluctuations, we saw that time is anything but fixed. It is not a uniform, linear force. It is malleable, bound to the very structures of reality itself. We ventured into the world of consciousness, where time becomes even more elusive. Our minds shape our experience of time, stretching it, speeding it up, and sometimes making it vanish altogether. What if time, as we experience it, is not an intrinsic part of the universe, but an artifact of our perception, a product of our consciousness, and our need to make sense of the chaos around us? The quantum vacuum showed us that time, at its deepest level, might not even exist. In the nothingness of space, where particles flicker in and out of existence, time vanishes. Could this be the true state of reality? Could time, as we know it, be a mere illusion, a fleeting narrative we tell ourselves to explain our experience in a material world? We also explored the cosmic scale, where the beginning and end of time are intertwined. The Big Bang marks the birth of time itself, while the eventual heat death of the universe suggests that time will someday cease to matter. But even in these grand models of the cosmos, we find contradictions and speculations. Could time reverse in the cyclical nature of the universe? What does time's eventual demise mean for our understanding of existence itself? Through each of these scientific and philosophical lenses, we have uncovered a truth that is as awe-inspiring as it is unsettling. Time, in its purest form, might not be the unchanging force we think it is. Instead, it may be a fluid, dynamic experience shaped by our perceptions, by our consciousness, and by the fundamental laws that govern the universe. It may even be an illusion, something our minds create to make sense of the world. But as we return to our original question, does time exist, we find that the answer is far from simple. The truth is, we don't know. We know that time governs our lives in ways that feel real, in the ticking of clocks, the aging of bodies, the unfolding of events. But as we've seen, this familiar experience might be only one layer of a much deeper, more mysterious reality. As we step back and reflect on all that we've uncovered, we find ourselves at the edge of something far greater than the mysteries of time. We are faced with the vastness of existence itself. What is the nature of the universe? What is the nature of our consciousness within it? How do we fit into a reality where time might not even exist in the way we think? And so, we are left with a profound sense of mystery. Time, as we experience it, may not be the constant we assume. It may be an illusion, a construct of our minds, shaped by both the physical universe and our consciousness. Or it may be something far more complex, something we have yet to understand, existing in ways that defy our comprehension. The idea that time might be an illusion challenges everything we know about our existence. It forces us to question not only the nature of time, but the very nature of reality itself. What does it mean to exist in a world where time may be nothing more than a story? A story our minds tell to organize the chaos of the universe. What does it mean to experience a world where time might be something we can transcend, something that we might one day be able to understand on a level far beyond our current comprehension? In the end, this documentary is not just about time. It's about existence, the mystery of the universe, the mind, and the world we live in. The more we explore, the more we realize that the true nature of time and of reality is something that we have only begun to touch. As you leave this journey, ask yourself, how do you experience time? How does it shape your perception of the world around you? And more importantly, what does it mean for your place in the universe? Could the reality you experience be more fluid, more mysterious than you ever imagined? We live in a world where time is real, but where its true nature may be far beyond anything we can truly comprehend. And as we step into the future, into the unfolding mystery of existence, we may come to realize that just as time governs our lives, we govern our understanding of time.